Good day, I'm Elizabeth Ramos. I'll be discussing about the four basic concepts in the mathematical language and symbols. First, let's think about the language of sets. Set theory is the branch of mathematics that studies sets, introduced by a German mathematician Georg Cantor. Now, what is a set? A set is a well-defined collection of distinct objects. It usually represented by capital letters. The objects of a set are separated by commas. The objects that belong in a set are the elements, denoted by the symbol or members of the set. It can be represented by listing its element between braces. A set is said to be well-defined if the elements in the set are specifically listed. Take a look at the given sets, which is a well-defined and not well-defined set. Okay, set A is a well-defined set because we can easily listed the elements which are the vowel letters, while set B is not a well-defined set because we have our own definition of the word beautiful. Here are some examples of sets. Next, the notation. So if S is a set, the notation, the first symbol means that X is an element of S, while the second symbol means that X is not an element of S. So the only difference is that there is a slash in the element. A variation of notation is used to describe a very large set. So in the given example, if we will define the elements inside the set, it means that the set of all integers from 1 to 100 because it started from 1 and ended in 100. Then the symbol, the three dot, is called an ellipsis and is read and so forth. So ellipsis is used if the elements inside the set are too many, like in the given example above. There are two ways to present sets, either by roster method or by row method. Roster method, also called tabulation method, is when the elements of the set are enumerated and separated by a comma. For example, set E is a set of elements A, E, E, O, and U. While row method, also called set builder notation, is used to describe the elements or members of the set. The symbol is written as the set of X such that P of X. For example, set A is a set of elements X such that X is a collection of vowel letters. Next, the cardinal number of a set. Cardinal is the number of elements or members in the set. The cardinality of set A is denoted by this symbol. For example, set A is a set of the elements of the vowel letters. So therefore, its cardinality is 5, since the elements inside the set have 5, namely the A, E, O, and U. Then, let's have the types of set. First, the finite set. A set with limited or countable elements and the last element can be identified. So for example, set C is a set of the elements D, I, R, and T. So its cardinality is 4 since the elements are D, I, R, and T. So we only just need to count the elements inside the set. Next, the infinite set. A set whose elements are unlimited or countable and the last element cannot be specified. For example, set n is a set of counting numbers 1, 2, 3, and so forth. So, this example is infinite since we cannot determine or cannot specify what is the last element in the given set. And that is why its cardinality is infinite. Next, unit set or singleton set. So is a set with only one element. So for example, set J is a set of letter W. So its cardinality is 1 since the only element is letter W. Then a unique set, also called empty set, denoted by braces. It can be null set denoted by null. So a unique set is a set with no element. For example, set L is a set of x such that x is an integer less than 2 but greater than 1. So its cardinality is 0 since there is no integer between 1 and 2. The universal set, denoted by the symbol capital U, is the set containing all elements and of which all other sets are subsets. For example, set A is a set of elements A, and R, and B is a set of T and H, and all the elements in set E and B are present in the universal set which form the word Earth. Then subset, denoted by that symbol. Set A is a subset of set B if and only if every element in A is also an element in B. So for example, set A is a set of elements C, D, E. Set B is a set of elements E, B, C, D, E. And the universal set compose all the elements in A and B. So therefore, a is a subset of B, since all the elements in E are present in B. Then proper subset, denoted by that symbol. Set A is a proper subset of B if there is at least one element in B not contained in E, while that symbol denotes not a proper subset if and only if every element of E is in B and every element of B is in E. For example, set E is a set of elements C, D, E. Set B is a set of elements E, B, C, D, E. Set C is a set of elements A, E, C, B, D. And the universal set who's composed of all the elements in set E, set B, and set C. So we can see that A and C is a subset of B. But A is a proper subset of B and C is not a proper subset of B. It can be noticed that A is the only proper subset of B, not C, because C and B have the same elements. Then the power set, so denoted by that symbol. So it is a set of all the subsets of a set. The formula to use is the power or P, then open parentheses, the name of the set, then close parentheses equal to 2 to the power of n, or n, the number of all the elements. For example, set A is a set of elements E and F. So the formula is shown below. So we have two elements, therefore 2n is equal to 2 and equals to 4. So the power sets of the elements E and F are E, F, E, F, and a null. So we are done with the type of sets. Let's move on to the operation on sets. So let's first differentiate the union and intersection of a set. So a union of a set is the set of all the elements, while the intersection of a set is the set containing the elements that are in both A and B. For example, set A is a set of the elements C, D, E. Set B is a set of elements E, B, C, D, E. And the universal set whose compose all the elements in A and B. So their union are the elements E, B, C, D, E, while the intersection is the element C, since they only overlap in the element C. Next, the complement of A or absolute complement of A is the set of all elements in the universal set that are not in A. So, di ba sa yan, Rasia, ayun tatanaw sa illustration. So, the only element na wala daw sa set A. So, the answer is F is the element F and J. Next, difference of E and B or relative complement is the set of all elements X in U such that X is in E and X is not in B. So, ang ato ng pangitaon is ang element nga naa sa E but wala sa B. So, from the given example, ang ilang mga related or naa nilang duha is sa element C. So, the answer is the element E and B. Then, lastly, the symmetrical difference of two sets is a set of elements which are either in A or B, not in both. So kaniang sad is naa sa E ug naapod sa B, but wala nilang duha. So the answer is the elements A, B, D, and E. Then what is a disjoint or non-intersecting? So if and only if they have no elements in common. So ang disjoint or non-intersecting is kung wala sila'y element na pareha sila. Like in the given example. So set A is a set of elements A, B, C. Set B is a set of elements D and E. So therefore, it is a disjoint or non-intersecting. Then ordered pairs, so we have E and B. So A is called first component, B is called the second component. But in general, EB is not equal to BE. For example, we have the ordered pair 2 and 5. So 9 minus 7 and 2 plus 3 is equal to 2 and 5 ordered pair. But 2 and 5, 5 and 2 is not equal to 2 and 5. So see the difference. Cartesian product of sets A and B, written A times B. So for the Cartesian product of sets A and B, the only thing that we need to do is multiply all the elements in E to B. So like in the given example, we have set A is a set of elements 2, 3, and 5. Set B is a set of elements 7 and 8. So what happens is we have first the 2 and 7, 2 and 8, 2 and 8. Then 3, 7, 3, 8, 5, 7, and 5, 8. And that is the answer. Then let's go on to the language of functions and relations. So what is a relation? So a relation is a set of ordered pairs. So we have done talking about the ordered pair. So that is the example of ordered pair. Then the set of all first coordinates is the domain X of the relation. The set of second coordinates is the range Y of the relation. So from the given example, our domain are 1, 2, 3, also called the input. And our range are 1, 3, and 5, and that is our output. So relation as a subset. So we have here an example. So set A is a set of the elements A, B, C, D. Set B is a set of elements S, T, U, B. So the relation as a subset. So ang atong buhaton is, as like the Cartesian product, we just only need to multiply the elements of A to B. So, ang nahitabo is maan ni siya. A, S, A, T, A, U, A, B. Then B, S, B, T, B, U, B, V, C, S, C, T, C, U, C, V, 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 D, S, D, T, D, U, and D, V. And that is the relation as a subset. Then lastly, what is a function? A function is a relation where each element in the domain is related to only one value in the range by some rule. A function is a set of ordered pairs x, y such that no two ordered pairs have the same x value but different y values. So in short, sa function, dapat ang value sa domain or sa x is dapat isara bahala og daghan og value sa y value or sa range. Next, representation of functions. So, we can represent the functions by the following. First, by a table of values. Second, by mapping. Third, ordered pairs. Fourth, graph. And lastly, by equation. Then let's have an example of a function. So the figure 2.1 is a function because as we can see, the domain has only one value to the range. Another example. So in this figure 2.2, it illustrates the relation of a domain and range of the given ordered pairs. Relations E and B are functions because for each x values, there is only one value. Notice that in B, the last two ordered pairs have the same y value, but this does not violate the definition of a function, since each first component, the x value, has only one second component, y value. While relation C is not a function because the first two ordered pairs have the same x value but different in y value, and this violates the definition of a function. So, thank you for listening, and I hope you learned something from my discussion, and that would be all.